Hi students. Let's go over a quick analogy to help us understand Le Chatelier's principle. So before we can understand Le Chatelier's principle, we're going to need to understand chemical equilibrium. To understand chemical equilibrium, you have to keep in mind that most chemical reactions are reversible, meaning usually we write a reaction with our reactants on the left side and our products on the right side, and we're used to thinking of reactants turn into products. And that's true. But in reality, it's also possible for products to turn back into reactants. They can go the other way. So that's what we mean by reversible. And that's why we tend to write these types of reactions with this type of an arrow that shows that it's going in both directions. That just emphasizes that both the forward and the reverse direction are possible. So a reaction that is in equilibrium is one where that forward reaction and the reverse reaction are happening in the same amount so that we're in a nice state of balance. So it's in equilibrium, it's in balance. And so a helpful way to think about equilibrium is with like a little balance. So we can imagine we have like a seesaw, and there are reactants on one side and products on the other side, and in chemical equilibrium they will be in balance and that seesaw will be nice and flat. So this is the analogy we're going to use to help us understand Le Chatelier's principle, is this seesaw. Okay, so what is Le Chatelier's principle? So this states that when a change is applied to a reaction, the equilibrium is going to shift to counteract that change. So it's going to try to do the opposite of whatever happened during that change. So let's think about our little seesaw. So it's saying that if we shift the seesaw one direction, Le Chatelier's principle says we're going to undo that change to get it back to balance. So let's look at a specific example. So let's say that we have our seesaw and we add some reactant to one side. So if I added some reactant to one side of the seesaw, what's that going to do? It's going to push it down on that side. It's going to push on this side of the seesaw and make it heavier. So it's going to look like that. So that is our change. We have shifted it that direction. So to counteract that change, what do we need to do? We need to push the seesaw in the other direction. And that would essentially be making more products. And now we've evened out our balance. We're back in equilibrium. So once again, Le Chatelier's principle, what we need to know is that the equilibrium is going to shift to counteract whatever change occurred. And there's essentially two ways that that equilibrium can change. We can have the equilibrium shift towards the product, so it's making more products. The way that we would say that is we would say the equilibrium shifts in the forward direction or in the right direction. Right, like to the right. So that just means we're making more products. On the flip side, we can also say that we need to make more reactants. So we're going to have the equilibrium shift in the reverse direction or in the left direction. So that's essentially how we always talk about these changes. We talk about the direction in which the equilibrium needs to shift. So either it's going to need to shift forward or it's going to need to shift in the reverse. Let's do a couple practice problems to just make sure we got it. Okay, so same thing. We have A plus B makes C plus D, and we have the double arrows to tell us that this is a reaction that is in equilibrium. So let's think about our seesaw. So how will the equilibrium shift if products are removed? So let's take away some products and think about that seesaw. If it wasn't balanced and we took stuff away from the products, how's it going to shift? Now the reactants are going to be heavier, right? So it's going to shift this direction. So that was our change. So now Le Chatelier's principle says the equilibrium is going to shift to counteract that change. How do we counteract this change? Well, we need to push it back to the product side, right? So in other words, we need to add more products. So we need to shift the equilibrium to the right, or we need to shift it in the forward direction to get back to our balance. Let's do another one. Okay, here's one with like an actual chemical equation and not just A's and B's. So how will the equilibrium shift when some NO2 is added to this system? So same thing. Let's think about our seesaw. This is us in equilibrium. If we're adding NO2, NO2 is a reactant, so that means we're adding reactants. Think about how is that going to shift the balance? It's going to shift it that way. So now Le Chatelier's principle says we're going to counteract that change. What do we need to do to counteract this change? We need to push it on the product side, right? In other words, we need to push this reaction forward, or we're going to shift the reaction in the forward direction or to the right in order to make more products and get back to balance. Okay. You can also use the same principle with like the seesaw shifting idea if you're talking about endothermic and exothermic reactions. So in these types of reactions, energy or heat is a reactant or a product. In this example, this reaction is endothermic because heat is absorbed. In other words, heat is a reactant. So let's set up our seesaw first. So I put our reactants here and our products here, and then you can just think of energy itself like a reactant. So I'm just going to put a little fire there to represent that energy. And then the question says, what will happen if the temperature of the system decreases? In other words, we're going to have this energy and we're going to make it less. So it used to be like this, and now we're taking away reactants. We're taking it away. So now it's going to be imbalanced. We're going to have too much product, so it's going to be like that. Okay, so now think, how do we shift? How do we counteract that shift? We're going to have to move our seesaw like this, right? Which means we're going to have to push the reaction backwards in the reverse direction or to the left in order to get back to where we were before. So this one I like also because for me, the energy thing seems a little bit more intuitive. The temperature of the system decreased. It makes sense we're going to shift the reaction in the direction where we're making more energy, where we're making more heat, because that's going to raise the temperature back up to where it was before. And that's really it. That's how you do all of these Le Chatelier principle problems. You just think about it like a seesaw. Like I said, I literally take my hands and go like this and think about what direction I need to shift the equilibrium in order to make predictions about how it's going to change. And that's it. I hope that was helpful.